Well, so let us solve one more problem from CSIR NET 2020. Question number is 74, and this is basically from nuclear physics. Subtopic is nuclear liquid drop model. So in that question, that binding energy of a nucleus that is given, binding energy formula, that is A on A, then you have A2 a the power 2 by 3, and then A3 Z square a the power minus 1 by 3, and finally A4, then A minus 2Z, A minus 2Z square divided by A. So this is the binding energy formula. This is the binding energy formula for a nucleus that is given having mass number A, atomic number Z. And A1, A2, A3, A4, these are the constant coefficient that you know. This is volume energy coefficient, this is surface energy coefficient, this is Coulomb energy coefficient, and this is asymmetric energy coefficient. Also, it is given that A4 by A3, this coefficient is provided. That ratio is nothing but 30. Sorry, the question, they ask you to calculate the atomic number of naturally stable nucleus for a given isobar. For a given isobar means what? Having constant mass number. Okay, so as you can see from here, for an isobar, if A is constant, then binding energy is a function of atomic number. And for naturally stable isobar means, naturally stable nucleus means what? The nucleus having highest binding energy. So highest binding energy means maximum binding energy, and it's a function of atomic number. So what will happen for maximum binding energy, that dB by dz at z equals to z naught, that will be 0. It means for this atomic number, this differentiation will be 0. Now if you do it here, if you differentiate this function with respect to z, what will happen? We'll have first term and second term that will not survive, that will be 0. And third term, if you see, if we differentiate this with respect to z, what will happen? We'll have A3 that is constant and a the power minus 1 by 3 that is also constant, and that will provide you twice z naught. And then you have a next term that will be, if you differentiate it again, we'll have 2a4 a minus twice z naught, and again you have to be able to differentiate this factor with respect to z at z naught. So that will provide you minus 2 divided by a, and that will be equals to 0. Now if you multiply both sides, by a and divide by 2. So on the left hand side you will have this 2 will be cancelled. As a result, you will have minus z naught a3 a the power 2 by 3, because a the power minus 1 by 3, and you have a that will provide you a the power 2 by 3. Here you will have on 2 will be cancelled, minus plus, okay, and you will have f of course 2a4 a minus twice z naught, and this a will be cancelled with this a, okay, and on the right hand side 0 into this will be 0. Now if you rearrange it, what will happen? If you take z naught terms on side, and then you will get z naught into this term, that will be a3 a the power 2 by 3, and from here you will get another z naught, and that will be 4 a4, right? And that will be equals to how much? That will be equals to twice a4 into a, okay, this term twice a4 into a, okay. So now the z naught will be twice a4 a divided by how much? This will be 4 a4, then a3 a the power 2 by 3, right? Now if you divide divide by 2F4 in the numerator as well as denominator. So what you'll have, you'll have remaining A divided by 4F4 by 2F4, that will provide you 2, and then you have A3 by twice A4 A the power 2 by 3, which implies A divided by 2 plus A3 by 2A4. So as you have that given data is A4 by A3, that is 30. It means A3 by A4, that will be 1 by 30, and you have 2. That will make 1 by 60 A the power 2 by 3. Okay. Now if you simplify this, you'll get 60A divided by 120 plus A the power 2 by 3. So this is the atomic number of naturally stable isomer for a given data, from a given data. Okay, so this will be the correct option. Thank you.